Yeah, we'll start. In case others join, they'll join us as we continue. So today I was supposed to take you guys through control structures in Python. And control structures are basically most of the things you do inside your code. It's like the flow of your program or the execution of how things go in your program. In Python, we have a lot of control structures, but what I'll take us through today is the if statements, mostly the for loops, the while loops, and a bit of functions. We won't delve much into functions, but yeah, a bit of functions should do. So if statements basically, these are conditions that evaluate to either true or false. It's like a decision making process. So let's take example the temperature today. I believe most of us have widgets. You have a widget on your phone that tells you the temperature of the day. I do, for example. So where I'm at currently, it's at 23 degrees. So if the temperature is 23 degrees, so if temperature is greater than 23 degrees, mostly we'll consider this as hot. It's hot outside. So if this evaluates to true, so if the temperature is 23 degrees, is greater than 23 degrees, so print something. Let's say print it's too hot, something like that. So this is a condition, an if statement. Basically this is what an if statement evaluates to. It's if and then a specific condition which will evaluate to either true or false. So the result will either be true or false, and then what to do after the condition. Now the code to be executed. That's basically how an if statement looks like. So, okay, our temperature currently, let's have it as 24 degrees, and then run the program and see if it will print what I've talked about. So Python control structures.py, it's too hot. So what happens if the temperature is below 23 degrees? Let's say it's 20 degrees currently. Let me run the same code. So nothing is printed. Nothing is printed due to the omission of, if our condition results to true, then we have something to do. What about if our condition results to false? Let's say, what about when the condition is not false? When condition is false, so when the condition is false, we usually have an else block. I believe most of you have gone through the book we had shared, the resources we had shared earlier. So we won't delve much into this, but we have an else block. So this else block executes. So this one executes if our original condition fails. So if the original condition fails, then we'll execute our else block. Another way you can do this, you can come and change your comparison operator. Basically this is greater than, this is a less than sign. So if condition is less than 23, so this will evaluate to true. We shall print it's too supposed to be it's too cold, but anyway, I believe you guys get the logic. If I go too fast, you can just unmute and talk to me. So it's too cold. So this is an else block. So let me just return my original condition how it was. So if temperature is greater than 23 degrees, print it's too hot. Otherwise, it's too cold. So if I execute my Python code, I hope my screen is visible. I forgot to ask about that. Can you guys see my screen? Okay, thank you, Clement. Okay, so basically that's what the if else block looks like. So if this first condition is true, execute. So it's like decision making. If it's true, execute this. So you can add some logic here. Let's say you can wear a vest outside and shorts, or any other decision you want to make if the temperature is above a certain degree and all that. Okay, now this is a very simple control block, like if else statement. What about if you have many options to choose? Like the temperature can variate. It can be scorching hot, it can be too hot outside, it can be too cold, it can just be slightly cold, the evening breeze. What happens then? Because here you're only executing for two conditions. So this is where we introduce an elif block. For other programming languages, it's called something like an else if. In Python, we just shorten the words. It reduces too much typing time. So let's say the current temperature is 45 degrees outside. So if the temperature is greater than or equal to 45 degrees, this is scorching hot. I don't believe we can survive outside at these degrees. Anyway, who knows? So if the temperature is 45 degrees, it's too hot. What about when it's just a warm day? Not too hot, not too cold. So you can have an elif block. So if temperature is greater than, let's say, 20 degrees, that's not too hot, not too cold. So print it's a warm day. Something like that. So basically, the elif block allows you to add multiple logical statements to your Python code. So now if the temperature is 45 degrees and above, it will be scorching hot. You can just try something similar. So temperature, it's too cold, it's too cold. Okay, so we've run into an issue in our Python code, because logically speaking, if the temperature is equal to 45, let's say if it's equal to 45, that's an equal to sign, we should get it's too hot. If it's greater than or equal to 45 also, we should still get the same statement, it's too hot. Seems I had not saved my code earlier, but yeah, we get the same statement, it's too hot. If we have it below 45 degrees, something like 42, still too hot, but it does not meet our first condition. So it will execute with our second condition and evaluate to true. So it's a warm day outside. And finally, if the temperature is neither too hot nor warm, something like 10 degrees, we'll get it's too cold. So basically, this is the if block, or the if elif block, mostly used for making decisions. So that is the if statement. We'll combine all of these a bit later. Let me just go through them first. The next one, we'll talk about the for loops and the while loops. So a while loop, same to the if block something. A while loop just checks for a condition and it repeats your code or your logic as long as the condition is true. As long as the condition evaluates to true, the while loop will continue running over and over again. So it will have like an infinite loop. We can have something like, let me just say, comment this out. So this is what our while loop looks like. So while a certain condition, then do something. Basically, that's it. While a certain condition is met or evaluates to true, then execute the code here endlessly until the condition is no longer viable or is no longer met. So the simplest while loop you can have something like while true. So this always evaluate to true. So you can say while true, print hello, print hello world. So when our condition is met, our code should run infinitely. So as you can see, we are running the code infinitely, so it's just printing hello world until you either break out of the loop yourself. So we're using Control C to interrupt it. Otherwise the condition will run continuously, so it won't break. It will never break. The for loop, on the other hand, we use it to, what can we say, go through a list of something. I'll come back to this in a minute. Let's say the for loop, on the other hand, we use it to go through an iterable, or the iterables in Python. That is the lists. A string is also an iterable. The tuples. Yeah. So you can have, let's say, a list of toppings, something like tomatoes, cheese, pepperoni, I can spell that right, and some mushrooms. So this is a list of toppings, and you can use the for loop to go through each of these toppings one by one and print them. So you can have like for topping, in topping, list toppings, that is. Let's just print the topping. So what this will do, it will just evaluate, or not evaluate, it will go through these items in the list one by one and print the result. So we'll have the tomato, the cheese, every time our code gets executed. So these are the basic control structures we have in Python. So the for loop will execute until it reaches the end of the iterable. The while loop will execute until its condition is no longer met. That's why I was saying we'll come back to this in a minute. And the if statement just execute a block if the evaluation or the condition equals to true. If not equal to true, it evaluates either the elif statement if you have one, or the else statement, or it prints out nothing if none of the conditions are met. So the code just executes. So for the while loop, let's say we're talking about users. You have what can you say? You have an e-commerce site, or you have an e-commerce website, and you are looping through the users you have in your system and checking for a condition, whether they are confirmed or not. Yeah, let's have something of an example here. I'll just comment that out. Okay, so we have a list of unconfirmed users. Just go with random numbers for strings right now. Save up on time. So we have a list of confirmed users. So you want to loop through your unconfirmed users and maybe delete them, or delete them from the system. So you can have or confirm their status in the system so that they can be able to do some operations in your site, something sort of. So while you have unconfirmed users, while this condition evaluates to true, so you can pick a user and have the unconfirmed users. I'll introduce a function here called pop. It's a list function. Pop is a list function. It just picks, as you can see, just picks the index item at the last index of a list and removes it. So once you hover over a function in Python, if you don't know what it's for, there's usually some helpful information. So like a method, define something, then the explanation of what the method does. So this one removes and returns an item at a specific index if you set the index. If you don't, it defaults to the last index of your list. When your list is empty, let's say you pop and then you have an empty list. Like for confirmed users, we have an empty list. So if I have confirmed users.pop, let me save this. I should run into an error. Yeah, index error. So pop from empty list. You cannot delete from an empty list. So this is also a condition. The pop has a condition or an if condition. So what it does, it checks if your list is empty. So we can have if confirmed users, then pop. So this is also a decision. So we can just return this if confirmed users, then pop. Select the last user from the list and remove them. Otherwise or else, you can have user equals to unconfirmed users dot pop, or you can just print no users in the current list. Yeah, so no users in the confirmed list, and if our condition is met exactly, so while unconfirmed users, so this condition will always evaluate to true because our unconfirmed users is a list of 3 users. Let's say user number 1, 2, 3. If confirmed users, that is, if the list has a user, perform this action. Otherwise, print no users in the confirmed list. And as you can see, the condition continues executing endlessly. So it will run endlessly because I have not set a break out of this loop. And that is what I wanted us to do now. So let me just remove this and stop this from running. Consumes a lot of resources. So we can have user in unconfirmed users. So pop. So we'll take the user number 3 and remove them from this list. Let's say print. We are confirming the status of this user. Of user. Then you can have a user. So basically I've implemented an F string to concatenate the 2 strings. And you can have the user that you've popped out of or you've deleted out of the unconfirmed users into the confirmed users. So we can have .append, also a list function. What .append does, it just takes the value you're going to add here, let's say user, and adds it at the last index of a list. So if we have this list, so it's empty, and I have my empty list .append 1, this list will evaluate to 1, so it will have the value 1. If I append another value, let's say empty list .append 2, then the list will now grow, so it will have the value 1 original and another value of 2. So you can continue doing this, appending at the last index of your list forever and ever until the end of time, if you will. Yeah, but let's run our Python code. So we want to confirm all these users so that they can be able to do some operations in our system. While unconfirmed users, pop out the user, then to confirm them, that is, just add them to the, what can we say, add them to the other list. I hope you've understood what pop does, Clement. I'm now seeing your chat, sorry for that. If not, you can just have something. Let's say we have, it's simple. Yeah, you can just
sijaelewa kusema kweli.
Haina shida. It's okay. We can go through it again. Okay, so we have our list. Our list contains a number of integers 1, 2, 3, right? So in your number of integers, the pop method basically it's sort of like delete. It works like delete. We want to delete specific items from our list. But what pop does by default, huwa ina delete the last item in your list unless you specify specifically. Let me just comment this out, just a minute. Let me comment this. Okay, let's say we have our numbers list. So we have number 1, 2, 3. So what we want to do, we want to delete number 2. For lists, I believe you are taken through lists last week. So for lists, we have the index way of accessing elements in the list. So you can have like your nums at position 0. This will evaluate to this. If I just let me just print that. I believe it will be easier. Let's go here for a minute. Okay, so we have our numbers equals to 1, 2, 3, 4. So we have our numbers list. So 1, 2, 3, 4. If I want to pick, let's say number 2, I'll have to use indexing to access the element number 2. But the index of element number 2 for lists, we start at index 0. So our 1 will be index 0, index 2, index 3, index 4. So if I pick number at index 0, I'll have an output of 1. Same thing to numbers at index 2, I'll have an output of 3. And if I go outside the range of our list, let's say something like 45, I'll have an index error. I am outside the range of my list. Like I don't have 45 items in my list. So what pop does, if I want to delete items, let's say nums.pop, it will take the last index position, delete, and then return it. So as you can see, it just returned the number 4. But if I print my nums once again, the numbers list that is, I'll only have 3 items now. So it will be 1, 2, and 3 because number 4 has been deleted. If I repeat the process, let's say nums.pop once again, I'll delete number 3. I'm hoping you're getting the gist of this, right? Okay, that's nice. So nums.pop, it will delete number 3. So if I print my nums once again, I'll only have 1 and 2. But you can also set it. So now, just a minute to clear my OS. Okay, now I've reset our numbers to the original list. So if I have nums.pop and I set an index, let's say I set index at position 0. So this time round, number 1 will be deleted. So if I just do that and then return the nums, number 1 is deleted. So if you don't set the index you want to delete, it will just delete the last item in your list. Otherwise, it will delete the item at the index you've set. So that's what basically pop does. Yeah, I hope now you've understood. So let me just comment this out and comment out our while function. So if I run our yeah, so basically if I run a Python function, this is what happens. So if I pop, I'll just take this user number 3, confirm, and then print this statement. So take the user number 3, confirm the statement, take user number 2, confirm, user number 1, confirm, and since I am deleting the users, my list will keep on shrinking. So this condition will be met until this list of mine is empty. Let's say for the first iteration, when it loops through the first time, let me just print. I want to print the unconfirmed users list so that you see what is happening. Okay, so the first time we had the users, unconfirmed users 1, 2, and 3. So our condition was met. Our list had a number of users. So we popped the last user. We deleted the last user. So we are confirming the status of user number 3. That is the last user. Because as we noticed earlier, pop just deletes and returns that specific value. So we have 1 and 2 in our list. So the second time the loop runs, now we have 1, 2. So it deletes number 2. So it confirms the status of user number 2. We remain with number 1, user number 1 only in our list. And finally, we pop the user number 1. We confirm their status. And since our list is now empty, the condition equates to false. So the condition won't run anymore. Bit complex, bit easy, I'm not sure. I hope you've understood some control structures. Anywhere I can clarify, because now I want to move on to an example where we can combine all the things we've gone through. Okay, since you don't have any questions, I'll assume you've understood what we've been doing. Okay, now we have a scenario. Tomorrow is Friday, right? Some of you will go for parties, others won't. Basically, tomorrow is Friday, it's a weekend. You want to go out for drinks. You've gone out for drinks, you've gone out for a road trip. Now you're out there. It's 11 o'clock, it's 12 o'clock. You're deciding on how to go home. That's like a logical condition. You're thinking of what to do in that specific point in time, right? Just clear my terminal. It's a bad example, but I believe it will make the points we've talked about go home. So point number 1, you have friends who you've gone out with. So let's say this is a simple scenario. You are deciding on how to get home. After a night out, basically something like this. So you have the friends you went out with. This is like a variable. You can have like, we went out as 5 friends. What's the time that you're currently deciding on to go home? Let's say it's 2 o'clock or 2 a.m. where you are at. It's 2 a.m. It's 4 a.m. 6 a.m. also. Who's to say? Let's go with it's 2 a.m. How many of you are currently sober? 0, most probably. Or you have 1. And what is the distance from where you're at to your home? 20 kilometers, 10 kilometers. So these are your current scenarios. Let's have it as 10 kilometers. So these are the current scenarios you have. So you are deciding. So if you have some sober friends, and your distance from your homes, let's say to where you are at currently, is less than 10 kilometers, you can have a friend drive you home, right? You can have that one dedicated driver drive you home. So drive everyone home. So that's a condition. So if we run our condition, let's say, so if sober friends is greater than 1, so for this loop to be executed, both of these conditions have to make sense. Let's say this is the purpose of the AND condition. I'm sorry, I hadn't introduced this earlier. So let's work with this first. If you have more than one sober friend, I can drive you home, right? Drive everyone home. Okay, we'll nest a condition into this. Just a minute, so that it can make sense. So you have that one friend who can drive everyone home. Let's say the distance to your home is less than 10 kilometers for everybody. Okay, so you have that one guy who can drive everyone, and the distance is less than 10 kilometers. So drive everyone home. This is basically the condition I had set earlier. So the execution still equates to true, sort of. If let's say our distance is 20 kilometers currently where we are at, the first condition will equate to false, to true. So this will be true, but the second one will be false. So if I may ask, what happens here? What happens in this situation? The first condition is true, the second one is false. Manifest, it won't print anything. Exactly, so we won't have any output basically. So no condition has been met, and we don't have the else block to substitute. So if we had an else block here for this second print statement, second if block, we can have print, let's uber home, something sort of like this. So now if we run our function once again, yeah, so if the first condition is met and the second one is not met, so let's just uber home, safer and easier that way. So instead of having the multiple loops or multiple nested if conditions inside your code, that's why I had the AND here, because in order for everyone to be driven home, these two conditions must be met. So that's why I had the AND here, and I had AND distance less than or equal to 10. So this reduces the amount of lines we add in our code, and you can remove that so that we can have only the two. So the if block and the else statement. So if I do that again, we have the uber home. So okay, now we've checked for the condition that you have one sober friend and the distance, so you can be driven home. What about for the time? Let's say in your area you're only allowed to be outside from 6 a.m. to 10 p.m. Apart from these hours, you can easily get mugged, mapangale. So what happens? So you have that one sober friend and the distance is less than 10 kilometers. So we'll introduce another condition. So let's say the time. What's the time? So for the time, we usually have like 24 hours. So we'll go with the number of hours in a day. So if the time is, let's say, greater than 23, that's around 11 am, and the sober friends is equal to 0, that means you have none. What happens here? So you can have something like, let's take an Uber. We're just combining the different scenarios, let's say. So if you've noticed, in order to reduce the conditions like we had done earlier, we can have these as one block. So we can just remove this block here, have an AND statement here, and remove this block, becomes obsolete. So let's test for this condition to evaluate to true. So we remove this block and have the time as 2. So if the time is greater than 23, let's have it as 24, so that it can evaluate to around 12 o'clock in the night. Friends, let's have none of the above. Let's run our code once again. Okay, so let's take an Uber. So it's too late and none of us are in a position to drive, so let's take an Uber. If it's still early, which 2 am is a bit late, so our condition doesn't make a lot of sense, if you've noticed, because we are not accounting for the times from, that is around 1 am to about 6 am. 6 am. So what happens here? Because we have the time as 2 am, it's still quite late, but we are not getting any output. Our condition is not being met. What can we do to counter for this situation for the times between 1 to 6 am? Anybody in the chat? It's like an interactive session. We want to learn as we go. What condition can I add? Check for the time between 1 to 6 am. I'm using number 1 to 24 to account for the time. Ni zoom in ama ni kuelewa? Which is it? Okay. Sai?
Kama ni network yangu au mimi sioni hata screen yako.
Anybody else in the chat? Can you other guys see my screen? Okay. Clement, seems like it's an issue on your end. Too bad. Yeah, but anyway, it's almost 6 p.m. Let's just go through this. So, no problem. To account for the time between, let's say, 1 to 6, that is, we can have another AND condition here and check for the time and have it, since we have greater than 23, we can have less than, let's say, 6 am. Then we'll run our code once again, and come on. Okay, no problem. And our condition has not been met. So if time is greater than 23 and time is greater than 6. Okay, so logical error on my end. So for this statement to execute, the time has to be greater than 23. It also has to be less than 6. Makes no sense. So here we'll have to change our logical operator. So and all conditions have to be met for the condition to be executed. We have the or logical operator. So for the or, one of the two conditions has to be met for this to execute. And finally the not. The not just negates your condition. So currently, let's say our time is 2. So if I say if time is greater than, let me have it as less than, if time is less than 23, print time. Just a minute, I'll take you through these logical operators and then we continue. So we have time. If I negate these conditions, so if not time is less than 23, so basically just evaluate it to false, so I'll have no output. That's basically what not does. And checks if the condition is true for both of conditions. So if time is less than 23 but time is greater than something, let's say 1, then print time. So both conditions are met. So we have our time. So 2 is greater than 1 but 2 is also less than 23. And finally the or checks for either one of these conditions, if either one of these conditions evaluates to true. So if we have time is greater than 1, which is true, or time is less than 23, which is also true, then print time. Otherwise, if I have something like I can't find a scenario where time, the condition won't be met, but yeah, basically a short preview of the logical operators. So for these, I was talking about that so that I can sort of nikurekebisha our condition, correct the mistake I had made here. So if we run our code again, we can check it's too late, so it meets one of these conditions and we have nobody in a position to drive. So let's just print this statement. Let's take an Uber. So that one was checking for time, and we are checking here for if none of our friends are sober. Let's take an Uber. But what happens if the time is too late but we have one friend who is sober? So let's have 1. So this elif condition won't be met, so these won't execute. So we can choose to remove this condition here, then check for time. Since here we were checking for sober friends and distance, we can check for time here, see if the time is too late, and then if it's too late we can have the condition we had earlier to check for friends. So if it's equal to 0, I know it defeats the purpose of what we had done earlier, but logically speaking it makes sense. If we have nobody in a position to drive, then let's take an Uber. Otherwise, if we have somebody in a position to drive, that is like we have one guy who can drive, so let's print drive everyone home. Drive everyone home. Okay, so let's run our code. But here we have two statements that match. Let me just make one illogical. Okay, so what happens here? So first we check for the sober friends. We have more than one. We check for the distance. So our distance is greater than 10, so this condition evaluates to false currently. So then we go to our second condition, which is time. So our time is less than 6. It is not greater than 23, less than 6. So this evaluates to true. Then we come and check if we have 0 sober friends. So this evaluates to false. And finally we execute this block. So this condition wasn't met. This one was met. So we entered the logical or the next code execution into that block. Then we checked for the conditions inside our specific block. This is just nesting the conditions. So we nest them, then finally you can have the final else block. If none of these conditions are ever met, you can have something like call a friend. So the final else block. So this else block, this else block will belong to this if, elif, and condition. So you can just print call somebody to take you home. Basically. So let's look for a condition where none of these are met. So search for a condition where none of these are met. You can have let's see. You can have time as 7, so that these won't evaluate to true. The walking distance can remain as 20, so that this won't evaluate to true. So what will happen is our else block will run. So if I save this, and I run our code, so we have the function call somebody to take you home, the print statement. So here what happens, we just again check for the conditions. So the distance is greater than 10, so the time is not greater than 23, and it's not less than 6. So this block won't run, and this one won't run. So we'll just execute the else statement. That's basically most of it for the if else. Now to kind of spice up our logical conditions, we can add for loops to this specific code. So we can have you're out, there's a group of you, so a group of friends, that is let me just remove everything. So we can have groups of people first of all as a list, and a dictionary of the group of friends. So the number of friends, we can have it as, let's say, 4 for the first group. The time, we can have, let's say, 2 AM, and the number of sober friends, we can have, let's have 0, and the distance as 15. Okay, I'll just copy this so that we can have like 3 groups of people. For the second group, we can have like the time is 22. We can have 1 sober friend for this group, 5, and then something like 4. Let's say each. Okay, now for the for loop. Now you want to make the decision for these groups of people. So you have like 3 groups of people who are all different places, different things. They want to make logical decisions to evaluate what to do. So here we can have the for loop, as we said earlier. The for loop just goes through any iterable one by one. So if I print group here, for the first loop, we'll be evaluating this group, then the second group, and finally the third group. So we can have something like print let's say evaluating a group, and we can have, let me just introduce an else statement here. Evaluating the group at that specific point in time that our code is running. So for the dictionary, to access the elements in a dictionary, same as indexing to lists. So for like lists, we had what was this called, nums at position 1, nums at position 2. Basically it's the same thing with dictionaries, just that instead of having indexes to groups, we use what we call a key. So these friends will point to this value, this time will point to this value. I don't think we've gone through dictionaries yet, so I won't dwell much into it, but basically for dictionaries we have key value pairs. So the key is let's say the friends, and the value for friends is the number 4 or the number 3 or the number 6, depending on the group you are currently at. Same thing with time, sober friends, all that. We'll go into this. Let me just explain the purpose of for loops. So currently we are evaluating the first group, so we want to fetch the number of friends. So the number of friends will have group, and then the key friends. We want to fetch the time, similar. So let me just rush through this. The number of friends who can drive, and finally the distance. So same thing as earlier, but now we're evaluating for different people. So same conditions actually. I don't know why I deleted the other one earlier. Would have saved me a lot of time. Let's see if distance is sober friends. Oh yeah, and distance. And distance is less than 10. You can have print for the first group, someone can drive you home. Otherwise, if that condition isn't met and our time is greater than 23 or our time is less than 6 AM, that is, we can have print. We're also checking for sober friends here, so if we have none, then print it's too late, let's take an Uber. Otherwise, can print someone can drive, and finally can print something like call someone. So for the elif blocks, you can have as many elifs as you want. Let's say we can have another elif here, that is the else if statement, to check maybe it's a walking distance from where you are to your home. So you can have another elif statement to check for distance, something like less than, I think something like 4 kilometers you can walk. So you can print just walk home. So if we run this code of ours, we should get an evaluation for all 4 groups, all 3 groups. So we are evaluating the first group, which has 4 friends, the time is 2, the number of sober friends, and the distance. So it's too late. Let's take an Uber. So let's see what led to this. So the number of friends was 4. They had 0 sober friends. So the distance is less than 10, but they have no sober friends, so we skipped that. The time matches the second condition, which is time is less than 2, and they have 0 sober friends, so it's too late. Let's Uber home. For the second group, they had 1 sober friend. The time did not match any of these conditions, so they had 1 sober friend. The distance was less than 10, so we executed the first block, so someone can drive you home. And the final group, we had 0 sober friends, the distance was 8 and time was 1, so we matched this condition. So this is introducing the for loop or the for control structure together with an if block or if statement to encapsulate logical decision making, like the logics behind our code. So what happens? So first we go through the groups one by one, then check for the conditions. So if certain conditions are met, then execute something, then go to the second group, check for the conditions. If a condition is met, do it, execute the other one. Now this is set for if you have let's say this is if you have the input. What about when you do not have, let's say, the groups? You don't have the groups, so you don't have the input. What happens in this condition? So for this condition, you will have to fetch user input. You have to get the data from somewhere. So in order to fetch user input, we have to use the same variables, but this time around, since we don't know what conditions we are or how many people we are looping, we don't know the number of groups we are looping, we don't know how many people, we can just switch out the for loop for a while loop and have while true, so that our block will execute infinitely, an infinite number of times. We can have while true, then evaluating. So since we don't have this group, we can have simple message evaluating how you get home, something like this. So for the friends count, we'll have to get the count from the user or somebody interacting with your system. So since it's an integer, we are evaluating an integer, we'll use the int to typecast, and then we'll have the input. So we can have a question to ask the user, how many friends are with you or in your group? How many friends in your group? How many friends in your group? Then we can have what's the time, or what time is it? What time is it currently? How many sober friends? And finally, distance to your home. How far from home are you? Okay, now we have the same data we had the first time, and our loop executes just like earlier, so we're just doing the same things over and over again. But finally, since this loop will execute infinitely, we can have a condition. After running the condition here, we can have evaluate for another group, and we can have input from the user, let's say like continue, and you can have an option to either choose yes or no. And since we don't know how the user will insert their data, we can have .law. This is a string function, just takes the string that you input and typecasts it into a lower. Let's just show you an example. You can have city Nairobi. If I have the city, it will be Nairobi in all caps, just like how I set it earlier. But if I add city.lower, you can have like all lowercase. So this law is just for making sure no matter what the user enters, you can have a yes or no option. And finally, so if another group, so if the user enters no, so if user enters no, then just break. Break is a function to just exit out of the loop, like you can just stop the loop. So this will evaluate these to sort of like false, basically what is happening. So if we run our code now, so Python control structures. So we start with the first question. So how many people in your group? Let's say 4. What time is it? 2. How many sober friends? 0. And a distance of 15 kilometers. So this is the group we had earlier. In the chat, what is the output we will get for this specific group? Or you can just unmute your mic and give an answer. So we have 4 people in the group. It's 2 a.m. in the morning. So our second condition is met, and we have no sober friends. So basically we are going to get this output. It's too late, let's take an Uber. So yeah, it's too late, let's take an Uber. So for the final input, the continue, if we have the input as yes, let's say, we'll have the condition to evaluate another group. So this is what we were talking about, the while loop. So while this condition is always met, this will execute infinitely, an infinite number of times, until either we break out or something happens that changes the condition to false. So if I have the same conditions for the group, I can have 1 and then 13. Someone can drive, so yeah, we have this condition. And finally, if I insert no, we'll break out of the loop. So if this condition is met, just break out of the loop. So stop the code from running anymore. And I think that concludes control structures, unless anybody has a question. Does anybody have a question? Okay, I'm good. Okay, so should we continue the final example? We stop it at that, then we can reconvene next Thursday and look at functions. Kama ni mwa confused pia mnaniambia, perhaps I've talked too much and confused you guys. Okay, no problem. So yeah, I think that is it. So for conclusion, I'll take you through something simple I was working on, and then I'll leave you guys. So for this, basically a task management application, that is. So you have various functions to add tasks, view tasks, mark your tasks as complete and all that. And yeah, so these are the functions, the things you can do in your system. So as you can see, basically all I'm doing is having if-else statements in my code. If else, if else, if else, some for loops here and there, and then finally a while loop. So this while loop just runs infinite number of times, prompting the user for what the user wants to do, and then executing that command. So if you, let's just go through here. So add task. So if you have the task name, so just append a task to your tasks list up above. Otherwise, tell the user the task can't be empty, it should have a name. If the user prints tasks, you can check for the condition. So this is the not condition, the one that was negating the earlier command. So if this task is empty, just print no tasks to show. Otherwise, for task in tasks, that is status, if task is completed, else pending, basically just checking for the status, and mark as completed. So this is marking your task either done or not, just marking as an index and then deleting a task. Then finally a help menu to show the above conditions we've talked about, and a while loop to run through our code infinite number of times, so the user can add a task as they want. So if we run the Python control structures, basically what happens, you get a command output. So add, so you can have add task number 1. Let me just have add currently. So we have task name cannot be empty. So add task 1. Task 1 added. View task 1 with the status of pending. Delete task at index 1. View no tasks to show. Basically that is it. So I'll share this code in Discord. For those guys who are in Discord, you can go through it, try to understand it. It will help you grasp what we've talked about. But yeah, that is it. Thank you for attending. See you guys next Thursday.